Welcome back to the shop and to the channel. Well, if you've been following along on these videos, we've got this drive gear for my universal head on my Kearney Trecker 2HL machined, assembled, and installed in the machine. And now I think it's time to put it to the test, but I do want to check a few things first before I actually do that. Now, if you've ever done any work on an automotive differential, you may have come across this compound, this gear marking compound, that is used to check the mesh between the ring gear and the pinion gear. The idea being that if you paint this compound on the ring gear and you spin the differential, that where the pinion comes in contact with it, it's going to rub some of this compound off, and it'll let you know if the pinion is deep enough or shallow enough so that it rides within the center of the ring gear. So my hope is I might be able to use this compound to see how well this drive gear is meshing with the driven gear in the universal head. Or at least that's my hope. Since I know I'm going to be taking this on and off, I disassembled the head a little bit. I took off the drive bracket here that includes the driven gear from the rest of the unit, and this will just make it a little bit easier for me to mount it, do some tests, and then take it off and take a look at those gears to see where the marking compound may have transferred from one to the other or had been smeared. Well, with a socket on the drawbar, I can spin this by hand. So there seems to be some crunchiness in the gear mesh. So I'll take this bracket back off and take a look. Well, aside from that one smear on one of those gear teeth, I really don't see a whole lot of disturbance of the gear compound. So I don't really think that these gears are meshing very deep at all. And I have a theory I'm going to test. So a theory that I have here is that this spacer, which again, if you look at my previous videos, is designed to come in contact with a spacer, a similar spacer that's on the driven gear inside the drive bracket. And what it's intended to do is to keep these gears in the proper mesh so they're not too deep and they're not too shallow. As long as they're touching, they should be fine. And one of my theories here is that my drive gear here isn't thick enough, or it's not spaced out from the spindle far enough. And there's a few things I can do to try to adjust that, but I think the simplest thing for me to do is just to move the spacer out. So I have these 50 thousandths spacers or washers that I'm going to put behind this disc and just space it out just a little bit to see if that makes any kind of a difference. Well, I only have three of those washers, so these other two screws, I'm just going to lightly snug them in. I don't want to deform this disc at all and end up affecting my test. Well, with the spacers now behind that disc, let me put the drive bracket back on the face of the mill. Well, that's still sounding a bit crunchy. It didn't really make a whole lot of difference, but I'm going to try putting it under power and see how it does. This first test under power is only running at around, I think it's 60 RPM. I'm not hearing any gear noise in there, so I wonder what it would sound like at a bit faster RPM. Well, the faster RPM certainly made some more noise. What I want to do is go ahead and take this off again and see if there's any change in the uh, markings or lack thereof in the marking compound. Well, I'm a little bit frustrated here because this thing is making so much noise. It's louder on video than it is in person, but I was expecting to actually see something a little more definitive in the gear marking compound. I think I see something, but I'm not quite sure. So I'm going to put a little more of this marking compound in another spot that's a little bit lighter, maybe not so heavy as the first spot I've been testing with, and see if I can't, maybe notice it. Maybe I've got too much gear compound on here and it's just slopping all over the place, so it's not really giving me an indication of what's really there. The other thing I want to do is take this spacer completely out of the equation. So I'm going to remove it off of the front of the gear. So for now, instead of the spacer, I'm just going to use a couple of washers here that'll make sure that the gear stays on the front of the arbor here on the tool holder. Well, there's no real change in the sound, and again, the video is a lot worse than what I'm hearing in person. I do not feel any vibrations, at least not discernible vibrations in the bracket or the machine or anything around that gear. So I'm not exactly sure where this noise is coming from. But let me take this bracket back off and let me examine the gear and see if I can notice any marks in that gear compound now. Well, I'm actually getting a result here, even though it might be very difficult to see it right away. But right there and near the front of that tooth, you can see where some of that gear compound has been smeared away. So it is definitely making contact with the gear down in the root. But if you look a little bit closer, you can see that it's not just the gear compound that has been smeared. There's actually some wear in the root of the tooth of the gear. And if I look at the driven gear inside the bracket, you can definitely see that there's been some transfer of the gear compound to the driven gear, but you can also see some shiny spots on those teeth. So now I think I have figured out exactly what the problem is and why I'm not really going to consider it a problem. Let me zoom in on the drive gear just a little bit. Well, if I zoom in on the tooth profile of the drive gear, it might become pretty obvious to you as it did to me. And it may become obvious to you that I have two huskies, which is why there's a dog hair on the face of this gear. But it looks like Cooper, in his best efforts, had some tool deflection when making this gear, and the gear profile isn't quite parallel, the tooth profile that is. And if I zoom in a little bit further on the drive gear here, you can see how the hardened driven gear that's in the bracket is actually wearing away parts of this drive gear. And because this driven gear, here's a close-up of it, is hardened, it's really not doing any damage to it at all. So is this a bit inconvenient, maybe a little bit noisy? Yeah. Does it bother me much? Honestly, no, it doesn't. And I'm going to go ahead and give this gear a try and actually try to machine something. Well, I have enough confidence in this gear that I think it's time to make some chips. I have a 3/4 inch 2 flute end mill in the tool holder, and I made up a simple drawbar here out of some 5/8 threaded rod. Well, I have a piece of scrap here clamped in the vise. I've raised the table about 100 thousandths, so this should be about 100 thousandths depth of cut with this end mill. Well, that seemed to do okay. The surface finish isn't great, but that could be from a variety of factors, not the least of which is some rigidity issues I might be having with this machine. Mostly it's because the machine is not level and it actually does rock a little bit, which is probably not a good thing. So let's push this a little bit. I'm going to raise the table up to 200 thousandths and take another pass. So I'm cutting about half the diameter of the end mill So about 3/8 of an inch into the material, 200 thousandths deep. So this is taking a pretty significant chunk of material out of this piece of stock. One of the things that makes this particular universal head so desirable is its ability to swivel and angle just about at any point. So I'm going to loosen up the head itself and just kind of swivel it up here a little bit, maybe angle it around 20 degrees or so, and we'll take another cut off of our piece of material. Well, I think that's kind of cool that I can do this fairly easily. I think this is easier than knotting or tilting the head on the Bridgeport. So I could definitely see me favoring this if I needed to, cut a sloped or angled surface. So I've got another tool here I want to give a try and see what we can do with it. Well, I have this 3-inch face mill that I got in some auction lot somewhere. I don't even remember where. It uses square neutral inserts. I haven't used this obviously before, so let's give it a go. I use this app on my phone called FS Wizard for, starting points for feeds and speeds, and that's what I've done here too. This is 50 thousandths depth of cut. I don't remember what my RPM was when I recorded this, um, but it was right around what FS Wizard suggested I should use for a 3-inch 3-insert face mill, and so far it seems to be doing fairly decently. The surface finish that I'm seeing behind the cutter isn't great, but again, that could be just the fact that this is a roughing end mill. The corner radius on the inserts is fairly large compared to what I'm used to seeing on the lathe. Well, I tried another 50 thousandths pass. In hindsight, maybe I should have gone 100 just to see if it could take it. I'd be willing to bet you this thing could do 100, 150 thousandths, maybe even 200 thousandths without an issue. Again, the surface finish is not terrible, but it's also not great. I'm going to try maybe just doing a nice 10 thousandths cut. And slow down the feed rate and see if I get a little better surface finish with it. I'm wiping off some of the anchor loop here just on half of this piece just to see if there's any discernible difference in finish quality. Of course, I'd want to be running with some kind of coolant or lubricant, but this is just an experiment just to see if there's a difference. As I suspected, there really isn't any difference between the surface finish on the half that had anchor lube and the half that I wiped it off. One of the other things that makes this particular universal head so interesting is you can slide it out away from the column. With a number of the vertical heads, it's fixed in position, so if you can't get the table underneath your part, you can't do anything with it. With this one, because it has this spline shaft, and you may have seen the video where I had to remake this shaft, I can pull this whole unit out away from the column. I will add that this was not a lot of fun to do. It really didn't want to move. It was very difficult to move this away from the column. And I think it has to do with the fact that those gears are not meshing just right. And because they're not, it means that this bracket is just a touch higher than what it should be, which means that that spline shaft is a touch higher than what it should be, which also means that the holes for the overarms don't line up exactly where they should, so it's a little on the bindy side. I was able to get it, but it did fight me. Well, I have a different tool now in the spindle here. This is a 4-flute 3/8 inch end mill, and I'll just use it to clean up the surface on this other piece of material. I'll just take 25 thousandths off the top of it. Now, I got a lot of comments in the last video about these drive keys and how these screws were just going to shear off the first time I tried to use it. Well, they didn't. Could they maybe in the future? It's certainly possible that they could shear off, but quite frankly, you know, I don't really see that as being a problem because if they do, I'll just fix it. Taking a look at the drive gear, and it doesn't seem to be the worst for wear. There's definitely some wear in the teeth, but nothing that really kind of bothers me, especially since the driven gear itself seems to be in good shape. I did remachine a little bit on the spacer. I actually put a little relief in it to sort of make a spacer for the spacer rather than using those washers here. I just relieved back a little bit of the spacer. I do still see some marks in it where the teeth of the driven gear are somehow coming in contact with it. I'm not sure if that's happening on installation. I don't think it's happening while it's running because it's only in that one spot. Well, all of the tools did what I expected them to do. The surface finish on these is not spectacular, and again, I'm not sure if that's because of the material, because of the tool choice, or if there's something in the machine itself. The smallest end mill probably had the best surface finish of all of them. But again, I don't know if because of that drive gear is making, not quite meshing correctly, is that causing some vibrations that I just can't detect, but is making its way into the tool. It's possible. This big chunk of steel looks really good. When I took that skim pass, it really cleaned it up good. It's not, baby smooth, but it seems to be doing okay. The drive gear, even though it performed okay, it does need a little bit of improvement. And maybe sometime in the future, I'll have the ability to make some helical gears. So I might be able to use this drive gear to make its replacement. And I think the best place to store this thing is actually in the universal head. I'll just use the drawbar to draw in the drive gear holder, and it can just sit here until I need it. So the only thing left to do now is to clean up this mess. Well, I hope you enjoyed this video and the series. If you did, give it a thumbs up. Consider subscribing if you're not a subscriber. Believe it or not, about 75% of the people that watch these videos are not subscribers. And if they would just take a minute to hit that subscribe button, it doesn't cost you anything, but it certainly helps the channel grow. And a special thank you to all those patrons that are supporting the channel financially and those that have donated through PayPal and other means. Well, thanks for watching, and we'll see you on the next one.